Okay, we're going to do a little bit of section 3.1. This should be relatively straightforward because you've had this obviously in high school. So I'm going to go through this quickly. So we're going to talk about roots, right? What is a square root? Well, a square root, looking at this down here, if I'm trying to take the square root of a number, in this case 9, I'm asking the question, what number multiplied by itself would equal this number? So the square root of 9 is 3. Why? Because 3 squared, or 3 times 3, is 9. Okay, so pretty simple concept, right? A little bit of vocabulary. You have a radical, which indicates you are taking a root of some kind. The value under the radical is called a radicand. It could be numbers and variables or combinations. And then the index is what root am I taking? No index visible is a square root. Any other root you will see an index. So for example, down here, I have the cube root of 27. So they're asking what number multiplied by itself 3 times is equal to 27. The answer is 3 because 3 cubed is 27. Okay. So a couple notes to be aware of for an even index. Okay. So the index is a square root, fourth, sixth, eighth, so forth. There's two solutions, a positive and a negative. So for example, the square root of 9 is really not just 3, it's 3 and it's minus 3 or plus or minus 3 because if I square a negative number, a negative times a negative is a positive. And a positive square, of course, is a positive. So any even root means that they're always going to pair off. Even negative numbers will pair off to become positive. Okay. We'll often drop the negative root and do the primary root or the positive root, but in many instances, you do have to use both roots. Okay. An even root must have a positive radicand. Okay, that should be obvious. If I try to take the square root of negative 9, I'm going to get an error on my calculator, and the answer you might have to put in the software is D and E does not exist. Why? Because I can't multiply any number by itself and end up with a negative answer, right? So no negative radicands for indexes that are even. However, odd indexes, 3, 5, 7, you can have negative radicands, right? Negative 27 cube root is negative 3 because negative 3 times negative 3 times negative 3 will result in a negative 27. Okay. Here's some common perfect squares, perfect cubes. You should certainly know all the perfect squares 1 through 12, so you don't have to reach for a calculator. You'll get familiar, if you're not already, with some of these initial perfect cubes. 1, 8, 27, 64, 125. Fourth and fifth powers, you can use a calculator if you're not familiar with them. Okay, so we have some examples, and we did these in class, but we'll just go down the line real quick. Square root of 81 is 9. The square root of negative 81, it does not exist. The minus sign's outside, then it's just going to be a negative 9. Cube root of 8 is 2. Cube root of negative 27, negative 3. Fourth root of 81 is going to be 3. I'll show you how to compute that if you did not know it. Okay. Um, so let's take a look at variables instead of numbers. So here's an example. If I take a square root and underneath the radical, I have something being squared. So the x is the base, the 2 is the exponent. So if the exponent of 2 would cancel or be canceled by taking the square root. And so the result would be just x, and that makes sense because x times x is x squared, so that would be the square root. Okay? And understand that any even exponent can be rewritten as a perfect square. Now, you're not going to have to do this. I'll show you the shortcut, but just to illustrate, x to the fourth, I could rewrite that as x squared squared. Why? Let's go over here and review that any base raised to a power that is in turn being raised to a power you multiply the exponents. Okay. So here I have an exponent being raised to another exponent. So 2 times 2 is 4. Now notice that the square root of this outer square cancel each other out, leaving me just the base, which was x squared. X to the 8th, I could rewrite this as x to the 4th raised to the second power, because 4 times 2 is 8. The square root and the square outside cancel each other, leaving me the x to the 4th. Likewise, x to the 20th is x to the 10th raised to the second power. The square root and the squaring here cancel, leaving me x to the 10th. What I want you to notice, the shortcut will be that if you take the exponent on the inside and divide it by the index, the result of that division will be the exponent value of your answer. So 4 divided by the implied 2 is 2. 8 divided by the implied 2 is 4. 20 divided by the implied 2 is 10, so forth. So it makes it very easy to take the roots of variables with exponents. And just real quickly, 3 divided by 3 is 1. Well, x to the first is just x. 6 divided by 3 is 2. 27 divided by 3 is 9. You get the idea. 25 divided by 5 gives me an exponent of 5. 24 divided by 4 gives me an exponent of 6. Okay? Now, combination of numbers and variables should present no problem. Square root of 100 is 10. Square root of x squared is x. So there's your answer. 144 square root is 12. M to the 50. Well, 50 divided by 2 is 25. So m to the 25th. The 7th root of 128 is 2. I'll show you how to compute that. And then r to the 14th, the 7 roots, 14 divided by 7 is 2. So 2r squared. 125 cube root would be 5. The cube root of y to the 18th, 18 divided by 3 is 6. 27 divided by 3 is 9, so there would be the answer. Now, for example, 128, if you didn't know what the 7th root of 128 is, which why would you, then on your calculators, you don't have to have a TI-84, so I'm going to show you how to do it on any calculator. You're either going to have this caret key, which is raising something to a power, or you might have a key that has an x raised to the y. In either case, you type in your base, you hit the exponent, and then the exponent will be 1 divided by whatever the index is. It's safe to put it into parentheses. So if I type in 128, hit the caret, in parentheses, 1 divided by 7, that's the 7th root of 128, I get a 2. Same, 128, x to the y, and then I type in parentheses 1 divided by 7, the result is 2. That is the 7th root of 128. Okay. Okay, so that's pretty basic. I'll move on and do another video for 3.2.